Hello and welcome to a Thorogood Associates webcast. Today we'll be covering how you can effectively work with real-time manufacturing data on a modern data platform. In this case, we'll be focusing on Databricks. And we'll be giving a brief overview and demonstration of some of the features available on the Databricks platform. So here is a brief agenda of what we'll be covering today. We'll start with a brief introduction to Thorogood, who we are and what we do. Then I'll go into some of the specific challenges that we see with manufacturing data and working with that manufacturing data, before going into a comprehensive overview of some of the features in the Databricks platform. Some of these are listed on the screen here, and we'll go through these each individually. Then I will pass you over to my colleague Aaron, who will go through a demo covering all of these features in a manufacturing context. But first, I've just mentioned Aaron, but I'll give you a brief introduction of the presenters for today. So my name is Ethan Hinton. I'm a data and AI consultant based out of our London office. I've worked with many of our customers for a wide range of industries, building out modern data platforms on Databricks and on other platforms. And you'll be hearing from my colleague Aaron a little bit later on in the session. Aaron's also a data and AI consultant based in our London office with experience building solutions on Databricks. So I will start by talking a little bit about who Thorogood are and what we do. So we're a global data and AI consultancy firm specializing in end-to-end solution delivery, data architecture design, tool training, application support, and data strategy. So even though in this webcast we'll be talking about Databricks specifically, we're also an independent consultancy and we work with a wide variety of vendors. This really allows us to recommend the tool set that best suits our customers' needs. So in this session, I'm going to talk about a number of Databricks features that make working with manufacturing data a lot easier and the reporting and analysis of this data more effective. We're using the example of manufacturing data specifically because many of the features of manufacturing data make it especially relevant to some of the Databricks tools that we're going to discuss. But the tools are widely applicable to other data types and use cases, so don't switch off if you don't work with manufacturing data. So what are some of the characteristics that make manufacturing data so unique? So firstly, with manufacturing production lines recording sensor data in real time, there's a strong need for this data to be analyzed in real time as well. This production line data needs to be continually ingested into your data platform and through to reporting and analysis without disruption or downtime. And to go alongside this real-time information, there's also a whole host of other data sources that link in with this data, such as data from ERP, CRM, and quality assurance systems. And although this data is often more static, it often needs to be merged or joined with the high-velocity data from the production line. And finally, there are strict quality and compliance requirements that need to be met. Data needs to be traceable, of high quality, and have strict security and governance rules applied to it. So what kinds of features can a data platform provide that will help to address these needs? Firstly, to ingest and transform high-velocity data streams, we need some sort of real-time data ingestion functionality, which will check for changes in source data at a high frequency and stream this data into our platform. To tackle the complex data relationships that exist in many systems, we require flexibility in transformations, simple reporting for users, and natural language querying capabilities to allow non-technical business users to get insights from their data without having to write any code. And finally, data quality enforcement and lineage tracking will be crucial to enforce quality and compliance requirements across the organization. And as you probably guessed from the title of this event, we're going to show you how the Databricks platform specifically implements these features and how you can set them up quickly and easily. And for those of you unfamiliar with Databricks, it's a unified analytics platform that runs across cloud vendors, and it really changed the way organizations manage their data by introducing the idea of a lakehouse, which combined the structured and governed nature of data warehouses with the flexibility of data lake storage. Databricks was founded by the creators of the open source Apache Spark framework, and Spark provides the base of how Databricks operates through Databricks Spark notebooks. But Databricks has a whole host of other features that make the development and governance of data pipelines and products faster and simpler. And this is really what we're going to cover in today's webinar. The first of these features is Delta Live Tables. Through supporting Spark, Databricks also supports Spark structured streaming. And they've developed an abstraction on top of this called Delta Live Tables. Delta Live Tables handles a lot of the complexities of setting up streaming pipelines for your data, making development easier. So once data is in your platform, Databricks apps and dashboards provide simple interfaces for users to visualize and interact with that data. Databricks Genie brings natural language querying capability on top of your structured data. And finally, Unity Catalog is the governance tool that links all of these services together. So let's dive a little bit deeper into each of these features, starting with Unity Catalog. The concept of Unity Catalog stems from the idea of the data lakehouse architecture, which can simply be thought of as storing all of your data inside a data lake and bringing structure to this data using a data catalog for metadata management. Unity Catalog is Databricks' offering of a data catalog. It reads the metadata of your structured files stored in Delta format inside your data lake and presents this in a catalog schema table hierarchy in the Databricks platform, just like in a data warehouse. But Unity Catalog brings a lot more to the table than just an interface on top of your data lake. It also allows you to integrate unstructured data into your platform, automatically track data lineage as you transform that data, monitor the data quality of your data using data quality checks, and it also brings a whole host of machine learning tools such as machine learning model versioning and dataset tracking. Delta Live Tables is the tool that will allow us to bring through our manufacturing data in near real time. Its main use is an abstraction over Spark structured streaming, which can be challenging to work with, requiring a lot of configuration to make a well-functioning pipeline. The Delta Live Table syntax is more declarative than with direct structured streaming. This really allows developers to focus more on the transformations they want to do to their data rather than the low-level details of how the transformation will be done. DLT also makes it easy to define data quality checks and actions when a table is defined in code, with this being built into the DLT syntax. These features make it simple for developers to increase the reliability of their streaming data pipelines. And the abstraction of underlying Spark execution means that Databricks can optimize this for efficiency, again removing the need for the developer to undertake this optimization exercise. Now, once our data is inside the platform and transformed using Delta Live Tables, we'll probably want to visualize that data in some way so users can track important metrics. Now, when you think of data visualization tools, you're probably thinking of dedicated tools such as Microsoft Power BI or Tableau. And these are best-in-class tools with a very wide feature set, making them the clear choice for enterprise dashboarding. But the downside of these tools is that even to make a simple dashboard on top of your data, you need to go into a separate application and ingest that data. And for real-time data moving through your platform, having a visualization tool inside the same platform as your source data means that insights are shown on the dashboard faster than with an external dashboard. Due to this, Databricks has introduced dashboards as part of their platform, allowing users to create simple interactive dashboards on top of data stored in Unity Catalog. These dashboards aren't as feature-rich as offerings from Power BI or Tableau, but they do provide a quick way for users to analyze data and trends inside the data platform. And alongside these dashboards, SQL query-based alerts can also be set up to monitor critical data sets for issues and notify relevant users. And you'll see this in action shortly in Aaron's demo. But often users find that they need custom insights that are surfaced via more ad hoc queries than in curated dashboards. And often the only way of retrieving this data is through querying the data source directly using SQL. If the user doesn't have the knowledge of the exact data set or of the SQL language, they require a data analyst to query this data set and present the outcome. Databricks Genie aims to cut out the middleman in this situation, using an AI model combined with Unity Catalog metadata to enable users to ask questions of the data in natural language and receive responses in natural language tables and custom visuals. Now, the final Databricks feature I want to run through with you before we go to a demo is Databricks Apps. So when choosing how to develop tools for users to interact with the data in your organization, there's a scale which we can plot various tools on, which balances simplicity and customizability. And we can plot some of the tools that we've already talked about on these axes. We can put Databricks dashboards on the side of the more simplistic to work with, but quite rigid in functionality, with external dashboarding tools being only slightly more flexible, as these tools don't allow custom interactions with data or data input. For a long time, custom web applications have been the king of customizability for data applications, as a custom web app can support data input, visualizations, and custom tools such as chatbots. But this comes with the complexities of web app development, requiring dedicated software developers to build these tools and serve them on external platforms. Databricks Apps aims to simplify this web app development process. It does this by allowing you to create these web applications directly on the Databricks platform, with connectivity to Databricks features such as SQL warehouses, secrets, and machine learning model serving. Access to your web app is handled for you by using Databricks accounts. Development and deployment time is significantly decreased through the availability of templates for popular app types such as chatbots, which is something we'll show off in the demo, and the consolidation of the development and deployment process into one platform. And with that, I'll hand you over to Aaron, who will show you some of these features in action on the Databricks platform.
Thank you, Ethan. So in order to showcase some of these features, I'm going to walk you through a real-world example of how Databricks can transform raw production data into actionable insights in a fictional manufacturing plant. This plant generates live production data, including machine temperature, vibration levels, error codes, and details about the products being manufactured. We'll explore how this data is ingested with built-in quality checks and transformed through our silver and gold tables, allowing us to derive instant business-level insights, such as the number of products being manufactured in real time. Following this, we'll dive into a Databricks dashboard where we can track and visualize key production metrics like machine temperature. We'll also see how automated alerts can notify users of any anomalies, ensuring quick responses to any potential issues. Beyond dashboards, I'll demonstrate how Databricks Genie enables business users to use natural language and instantly get insights beyond predefined reports. And finally, we'll look at Databricks apps, which can allow users to query a wide range of unstructured research documents, helping teams diagnose and investigate the root cause of issues efficiently. By the end of this demo, you'll see how Databricks can empower both business and technical users to unlock the full potential of their live data, improving efficiency, reducing downtime, and driving smarter decision-making. So, to start off this demo, I'm going to be talking you through the Unity Catalog Metastore, and I'll navigate over to the Catalog area on the left. Here, you can see a selection of catalogs. These are the top level in your data scheme, and as you can see here, we have one manufacturing webcast. Within our catalogs, we have schemas, also known as databases, and these schemas can contain tables, views, volumes, AI models, and functions, and allow you to organize your data and models into logical categories more granular than just catalogs. If I expand our data schema, we can see that we have both tables and volumes. And within our tables, we have both static tables and streaming tables. In this case, our static tables are our bronze raw machine metadata and our bronze raw product metadata, and our streaming tables represent the flow of live manufacturing data from bronze through to silver and gold. If I click on a table, for example, gold machine performance, we can see an overview of the data, so the column names and the column types. You can add columns and tags as well. We can also see some sample data and the data lineage. We can also see the data lineage in graph form. And if I expand this backwards, say for example, we wanted to know where our location column came from. Here we can see that it came from silver machine data. And if I click on it again, we can see that that came from bronze raw machine metadata. Typically, these tables are static and updated periodically. However, with Delta Live tables, we can ingest the data live in real time so that we can react quickly. Delta Live tables are created using the same normal Databricks interface. And here we have a notebook which I've used to create these Delta Live tables. In the background, I'm currently running a script to create synthetic manufacturing data. And here I'm ingesting that data live. Here we can see using dlt.table, I'm defining my table, bronze production data, giving it a name, a comment, and table properties, so the quality is bronze. I'm defining my schema and the location from which the data is being read. Here, I'm also setting expectations of the data so that we ensure data quality. For example, timestamp is not null, machine ID is not null, and temperature is above 0. In this example, I'm using dlt.accept all or drop. So if any of these expectations are not met, then the data will be dropped and not progressed to the next stage of my medallion architecture. The rest of this notebook is just defining the logic for my silver joins and my gold business aggregates. Once we've written this notebook, we can use it in our DLT pipelines. So here is the Delta Live table workflow area. And you can see here, I've created a pipeline manufacturing data ingestion. If I click on this, we can see the flow of data from bronze through to silver and ultimately gold. We can see the number of records written and the number of records dropped. And if I click on this, we can see our data quality. So in this circumstance, 100% of our files have been written, which implies that we have no data quality issues currently. And now that we have this ingested data, we want to visualize it. We can do this using Databricks dashboard. And I'll now navigate over to one that I've made as part of this demo. Your Databricks dashboard is created on top of your data in your Unity catalog, and it's accessed through SQL queries. This is highly beneficial as you can filter the data as it comes in. So for example, for my machining data, I filtered for anything within the last 10 minutes, whereas my product data, I'm looking at anything within the last 24 hours. By hovering over the graphs, you're able to see some more information. So for example, in this top left graph, I've created a graph which is the rolling average machine temperature, which is the temperature of each machine across the last 10 minutes in 10-second windows. By hovering over it, I'm able to see more information, for example, the number of error readings, the machine ID, and the location, and I can filter by selecting one of these on the side. I can also filter here using filters across the whole dashboard. So far, I've been running a script that has been simulating data where everything is going to plan. But what if things don't go to plan? For example, what if there was a surge in machine temperatures? Databricks alerts can help by providing real-time alerts for your data. To highlight this feature, I've stopped running the simulation of good data and started running a script which will create more erratic data. And while that's starting up, I will now talk you through the alerts in a bit more detail. Here's my alerts page, and I can click on this machine temperature alert here. So, Databricks SQL alerts periodically run queries, evaluate predefined conditions, and send notifications if a condition is met. In this case, my SQL query is finding the temperature of each of the machine in the last window, and the trigger condition is if any of these are above or equal to 100. If this alert is triggered, and the condition is met, then an alert will be sent to the destination provided. In this example, it's my email address. I've scheduled this query to run every minute. So I have been emailed. This is the email I've just received, and I've used a template to define what information I see. So for example, the message alert, machine temperature alert, change status to triggered. And I've also written the template so that it returns a table of machine ID, time, and average temperature during this window. And as you can see here, machine 010 has had a temperature of 158.7 degrees. And now we can see how that has affected our dashboard. As you can see, there's been a big spike in temperature and also a big spike in vibration. Now that we've been alerted and we can see the issues that are happening, we want to understand how we can improve this. As part of this demo, I've ingested some research documents into our Unity catalog and set up a Databricks app to query them. Databricks apps provide the ability to query unstructured data, whether that's text data or else, from your catalog in an easy to set up environment. Apps are created and served using Databricks, and you can choose between template chatbots or data apps to more custom apps too, allowing you to best address your business needs. Here's one we created earlier using a template. What this model is doing is it's a chat model sitting on top of our research and development documents. And if I ask it the question, how can I improve the thermal efficiency of my machines? What this is doing is this will query your documents and find a result to best answer your question. And here you can see the model has responded. To improve the thermal efficiency of your machines, several strategies can be considered based on the information provided. It has then returned the documents which it has cited and the information from those documents. This allows users to query documents fast and efficiently, improving knowledge management and leading to faster and more effective responses within your organization. Additionally, what if we wanted to ask questions and find out information about our data which is not addressed in our dashboards? This is where Databricks Genie comes in. Databricks Genie is a conversational model which allows users to engage with their data through natural language and obtain insights without having to learn complicated tools or waiting to hear back from analysts. In order to set up a Genie workspace, all you need to do is choose some tables, provide a description of each of them, and provide some example questions. You can also increase the accuracy of the model by giving more detailed descriptions, for example, information on each column to give the model a better contextual understanding of your data. Here, you can see the Genie workspace. You can see my previous chats, I can start a new chat, and I can also see the description I provided of each of my tables, and some example questions. So once set up, I can ask questions of the data such as, which machine has had the most error readings? And what this does is this translates my natural language question into a SQL query and executes that SQL query. So here you can see this query identifies the machine with the highest number of error readings, providing the machine's name and corresponding error count. Laser Cutter 1 has had 6 error readings, and it's also provided us a graph too. This is a basic question, but you can ask more complicated questions too. One of the benefits of Genie 2 is you can show the generated code. Here, this shows what SQL code has been generated and executed if you want to refer back and speak to your analysts to double check. That concludes the demonstration. To summarize today's session, we've looked at how manufacturing data brings unique challenges due to it being very high velocity, having complex relationships involving multiple data sources, and there also being strict data governance and quality requirements through regulations. We've also shown how some of the latest features on Databricks can help organizations tackle these challenges. We've looked at how Unity Catalog can bring widespread governance to your data platform, tracking data as it moves through the platform for data lineage and data quality. We've also seen how Delta Live Tables make streaming real-time data through your platform simple and easy to manage, and that presenting this data can be done using tools in the Databricks platform, be that a simple dashboard to visualize trends or a full custom web application and Databricks apps. Finally, we've shown how Databricks Genie allows custom data analysis to be done by users throughout an organization, regardless of their data analyst skills. To conclude, I would like to thank you all for joining, and here are our details if anyone would like to reach out or hear any more of our content. Thank you very much.